Hi, my name is Avi, and I will present my work on denoising word embeddings by averaging in a shared space. And this is a joint work with Dagan and Goldberger. Training word embeddings suffer from a certain level of noise introduced by quite a few randomized steps in the embedding generation process, which stems from several algorithmic steps, including batch ordering, embedding initialization, negative sampling, and subsampling. Consequently, different runs would yield different embedding geometries of varying quality. This random noise might harm most severely the representations of rare words, for which actual data signal is rather weak. We propose a denoising approach through generating multiple embedding instances for each word and fusing them together. We are given an ensemble of several pre-trained word embedding sets where xit denotes the ith word representation in the tth set. Our goal is to fuse the embedding sets into a single average embedding that is hopefully better. This is done by finding a set of transformations and the target word embeddings by minimizing the following squared error term. Then the optimal shared space representation is simply the average of the projected embeddings. In the case where k equals to 2, meaning we want to fuse two sets, the optimal transformation can be obtained in a closed form using the Procrustes Analysis PA procedure. It involves using the singular value decomposition over this sum of outer products and then taking the UV transpose multiplication. Unfortunately, when we have more than two transformations to look for, that is k which is greater than 2, there is no closed optimal solution. If we want to fuse more than two embedding sets, we should come up with a different approach. So instead, we employ an approach named Generalized Procrustes Analysis. The issue of using this algorithm, which is impractical in the large vocabulary scenario, like in our case. We came up with an iterative algorithm that circumvents this computational cost. It is easy to show that iterating through these steps, the score of the objective is monotonically decreased until it converges to a local minimum. We refer you to our paper for further details and for the full algorithm description. To validate this approach, we trained word2vec, glove, and fast text embeddings using the same fixed corpus and vocabulary. In our experiments, we compared our denoised method with the original embedding models. And as an additional baseline, we considered also the naive average embedding model. We trained each of the models for 30 times with different random seeds in order to obtain the multiple embedding sets we need. First, we analyzed how our method improves embedding quality and consistency. Here, we trained a new transformation and checked the mean squared error between the embedding sets, which quantifies their matching. As observed after applying our method, the average score drops by an order of magnitude, indicating much better stability of the obtained embeddings. Here is a more fine-grained analysis, computed per word frequency, which is the x-axis in this figure. The embedding stability always increases with the growing word frequency. The denoised embeddings are notably more stable across the frequency range, with the error minimized early on and reduced most drastically for low frequencies. We evaluated the performance of our embeddings over lexical semantic tasks, including word similarity, analogy solving, and concept categorization, as well as over several sentence level downstream benchmarks. The results show that the denoised embeddings obtain better overall performance substantially for fast text embeddings, and especially in the case of rare words tasks. So to wrap up, we presented a novel technique for creating better word representations by training an embedding model several times, from which we derived an average representation. The resulting representations proved to be more stable and reliable than the raw embeddings, and also exhibit performance gains in many tasks. We suggest using our method particularly for training embedding models in the low resource setting and long tail scenarios. Thank you.